Okay, question 3 and question 4. Question 3, brilliant question, nice and straightforward. Doesn't really get a huge amount easier than this. The best way, I think, to do it is to draw a little table. Okay, so I like to say 2x squared minus 7x minus 3. And then over here I like to do an x and a 5. Okay, just to tidy that up, I'm just going to draw in table. Okay. There we go. So every time you see these questions, I would draw a table. Alright, I'll do a different colour for just inside here. So 2x squared times x. We're adding the indices. There's like a little 1 there. Okay, so when you multiply these terms, you add indices. Okay, minus 7x times x minus 7x squared minus 3 times x minus 3x. Okay, so the only difficult thing here is knowing to add the indices when you multiply. Okay, so if that was a 2, that was a 3 in here. 3 plus 2 would give you 5. A lot of people would do 3 and 2 gives you 6. Okay, so that's the only trick of it. Next line. Okay, nice and straightforward. Now, I know we've got a mark for this, and I've got a mark for this. Okay, so we're getting half of your breakout is worth 1 mark, the other half is 2. The third mark is grouping the terms. Okay, now because I've written these in the order I have, the squared, the x, the unit, the x and the unit, i.e. the indices getting smaller as I go down, I'm actually able to group these, or these will kind of group themselves. So the cube is on its own. See here, these terms are the same, and then these terms are the same as well. Okay, so this is on its own, this is on its own, these two are the same. Okay, so for the last mark, you just need to add them together. So 2x cubed, that's fine. 10 minus 7, that's 3x squared, that is a plus sign. Minus 35 minus 3, minus 38x, and then minus 15. Okay, and that's where you're going to get your third mark. Okay, nice and straightforward. Every time you do this, just draw your table and you're adding when you're doing your multiplication. Okay, that's the only tricky bit. Okay, on to the next one. So, circles. Let's get a page. Okay, so circles. Circumference of a circle. Now we should all know that, okay? And we should know the diameter is 2 times the radius. Every time you see a circle question, it's not a bad shout to write this down. Okay? And then right away I would say, well, what information do I have? What can I fill out? Okay. I know 30 and I know 240. So I can work out my diameter because I know that 2 times the radius is diameter. So the diameter is going to be 60 centimeters. Okay. And the circumference of a circle is going to be 3.14. For the non-calc paper, it's quite common to give you that, just so because you can work it out any take too long to work it out much more accurately than that. Times the diameter, which is 60. But we're not asked for the full circumference. Okay, we are asked for the major arc AB. Okay, which goes from here to here. Okay, goes all the way around. So if we were to use this equation, we would work out the circumference of the whole circle. Okay. So what we need to do is work out the kind of portion of the circle, right? Now that means actually this equation becomes times theta over 360. That's the fraction of the circle we're looking at. Okay. And we know what that is. We know it's 240 over 60. Okay. Over 360. Now that's a wee bit more complicated. Okay. But when you think about it, it does make sense. We're just multiplying the whole circumference by a portion. Okay, so this is just saying, well, what portion of the circle are you looking for? Okay, if it asks for the major length, see, this was our our question, it wanted this bit here. And it said, well, this is 180. Makes sense, it'd be half, wouldn't it? It'd be half the circumference. So 180 divided by 360 would give you 1 over 2. So you would times that by half. Makes sense. We've just got a slightly more complicated fraction. Okay? So 240 over 360. Having done all of these questions, off the top of my head, I can just say that gives me 2/3. Okay? So I'm going to rub that out and just write 2/3. Because I know 120 is a third, so 240 is 2/3, so 360. But if you didn't know that, then you just say, okay, well, I need to simplify it. So 240 divided by 360, let's cancel the zeros, so that gives me 24 over 36. And then you just divide by 2. Divide by 2, 3, 4, 5, just think whatever number works. 2 is usually the easiest one. They're both even, they'll both divide by 2. Okay, so 12 divided by 18, divide by 2 again, 6 divided by 9, and now dividing by 3. So that's 2 over 3. Okay, dead easy. Okay, divisibility rules. Usually, when it's even, it'll divide by 2. The trickiest divisibility rule is dividing by 3, actually. So if we've got 111, I know that divides by 3, because 1 plus 1 plus 1 is 3, and 3 divides by 3. Okay, I know that 81 divides by 3, because 8 plus 1 is 9, and 9 divides by 3. It's a good little trick, you know. So I know that 222 divides by 3, because 2 plus 2 plus 2 gives me 6, which divides by 3. Okay, so if you can divide by, if it's even, divide by 2, and if you know this to divide by 3, you've actually got quite a lot of bases covered. Okay, so we're here. First thing I think I would do is this part. Okay, so 60 times 2 over 3. Well, we can do 60 times 2, then divide by 3, or we can do 60 divided by 3, then times by 2, which is probably easier. So 60 divided by 3 is going to give us 20, times by 2 is going to give us 40. Okay, so 3.14 times 40. Okay, that is the same as saying 31.4 times 4, because we just times this by 10. Okay, so that's the same as saying 4 times 10, and we've just done the times 10 part first. And now you need to go back to doing your decimals. So everyone learns this first year and forgets about it. So here we go. What I like to do is ignore the decimal. You only need to have the decimal point in when you're adding numbers. So say you're adding 21.5 and 2.07. It's very important the decimal's in the right place, because everything's got place value. Multiplying is different. We can just ignore the decimal just now and we'll add it in at the end. Okay, so 31.4 times 4 can be represented this way for now. So 4 4s, 16. 4 1s are 4, plus the 1 is 5. And 4 3s are 12. Now, there was one decimal place in the question, so we're going to have one decimal place in the answer. I'm just going to draw it nice and right in there. Okay? If the question was 31.4 times 0.4, we could represent it this way as well. However, at the end of the question, there's 2 decimal places in the answer. Sorry, in the question. So there should be 2 decimal places in the answer. Okay, 1 and 2. So we need to move the decimal point over here. So it's 2 decimal points. Okay. So remember, when you're multiplying decimals, don't put the decimal in to begin with, but put the number of decimal places in at the end that represent the number in the question. Okay, and then units, something easily forgotten. Okay, so just the big equals 125.6 centimeters. Underline, underline. Okay, so your 3 marks for that one. You would get a mark for doing this part here, for doing your fraction. So that's your mark there. Substituting the rest of it incorrectly. So remember, in this equation is substituting. That'd be another mark. Tick. And then just for going all the way through with this, we'll do one more mark. 3 marks. Okay.